Awesome. 3 p.m. UTC on the dot. Welcome, everybody. I hope you had a fulfilling long break. I want to quickly go pass it on to Michael for the second last session, the penultimate session of the day. That is anatomy of a transfer. Michael, you ready?
Yes, here I am indeed, and happy to be back. Hold on a moment.
Take it away.
I am trying to do that very thing, that's my normal candidness. So, Miguel has conducted you in his inimitable fashion through how a Mojaloop transfer works, and in particular the technical side of things. Now, I have a reasonable amount of duplication of that material here. My presentation, I'm afraid, will be somewhat less technical than Miguel's is, of course, since I am someone more less technical than Miguel is. However, so I will go through at speed and try and cover a few things that Miguel perhaps did not reach. Okay, so a Mojaloop transfer then has 3 stages. First of all, discovery. Second, agreement. Third, the transfer. In the discovery phase, payer's DFSP identifies the owner of the identifier, and the payee's DFSP provides information that the payer can use to check they're sending to the right place. In the agreement phase, the payer's DFSP exposes the details of the proposed transaction. The payee's DFSP confirms that the account can receive the proposed transfer at the time and defines the terms under which the transfer will be accepted. It then puts a lock on the terms and sends them back. In the transfer phase, funds are reserved, so they can't be spent twice. The payee's DFSP confirms that the transfer conforms with the terms agreed, and the payee's DFSP provides all the other parties with a cryptographic key which they can use to confirm that the transfer has in fact completed. Transfer is completed and the switch records the transfer for use by settlement. So how does that work? Well, what you see in the green boxes are the actual API calls that will be made in a situation like this. So I want to send some funds. I go to the lookup service, which, as Miguel said, we have multiple identifier types, and each of those, if they are supported by a particular scheme, has its own oracle, as we call them, depending on the kind of thing that it is. And as Miguel said, this enables you, for instance, to say, if I want to use the third-party Pathfinder service, then I can do that, and that will tell me reliably which mobile network operator owns any mobile phone number in the world. If, on the other hand, I'm in a jurisdiction which doesn't have mobile number portability, I could tell very quickly just by looking at the number and checking that against the ranges which are issued to each mobile network operator. So it's up to individual schemes to decide how they want to implement this. Some schemes, for instance, will have phone numbers only for mobile money operators. Others will have phone numbers for mobile money operators and other kinds of institution as well. So Mojaloop allows you to have your own implementation of a lookup service if you want to. Miguel said that correctly that in most cases, the address lookup service doesn't need to know anything other than the entity that an identifier belongs to. There are some exceptions to that. Now, as you will see, some of these identifiers actually refer to transaction accounts. So a phone number for a mobile money operator or a bank account number or an IBAN number will refer to an actual transaction account, but others don't. So a merchant ID, an alias, those kinds of things, they don't refer to an actual transaction account. In order to ensure that people are not using, for instance, multiple identifiers to conceal the number of transfers that are going back and forth to a particular account, some schemes can require that when people register, when entities register identifiers, they include an identification of the transaction account to which that refers. And that means that where multiple identifiers are pointing to the same transaction account, the central service will have a way of recognizing that that is the case, and as I say, undertaking AML investigations. However, if that's not the case, then the request will go across to the actual payee DFSP, and the payee DFSP will respond, for instance, with the full name of the person who owns that account, or some identifier that will enable the payer to say, yes, that is the person I intended to send to. Sorry. That goes back to the original payer DFSP, which can now display it to its customer and confirm. And that's the end of the identification phase. So now we start on the agreements phase. The payer says, this is what I want to transfer. We allow different transaction types, which can be identified as part of the quote request. So that enables people to say this is a P2P transfer, a P2B transfer, or any of the other transfer types that we support. It also includes, for instance, information that says, if there are fees attached, this amount is the amount I want the customer to receive, or this amount is the amount I want to send. So if there are fees, that depends on whether I have to send more so that the recipient gets the same amount, or the recipient gets less, but I only send the amount I send. So all of that information is included in the body of the quotes message. That's passed through to the payee DFSP. And the payee DFSP now says, is this an account I recognize? Can it accept this transfer, or is it suspended for some reason? Are there any other reasons to reject it, such as, for instance, it may be blacklisted or greylisted? Now we define the terms of the transfer, which might include fees to be charged, commissions to be paid, and the overall amount as a consequence of that to be sent or received. And then I put a lock and an expiry on the terms. So I'm going to spend a little time now talking about security in Mojaloop. Now, as I've said before, Mojaloop messages are exchanged over the open internet. They're protected by 3 separate mechanisms, each managing a different level of security. So the first is mutual TLS. It uses certificate-based MTLS. Each message that's sent in the system is encrypted using a shared key, and it can only be decrypted by another organization in possession of that shared key, i.e. another organization that belongs to the Mojaloop scheme. And all Mojaloop messages are protected like that. The second level of security is non-repudiability. And this enables enables an institution to say, if it receives a message, to understand that it really did come from the organization that purported to send it. So if I get a message, let's say from Standard Chartered Bank, this enables me to say, yes, I can verify that it really was Standard Chartered Bank that sent that message and that it hasn't been changed since they sent it. The mechanism we use for this is JSON web signing, which is a standard openly available protocol. And the way it works is as follows. First of all, the sender of a message signs the content of the message using a private key. And that includes the body of the message itself and important fields in the header, such as the sending and receiving institutions and some other things as well. The signature is transmitted as part of the message header as well. When the recipient gets the message, they compare that signature with a signature that they generate using the sender's public key, which of course is available to anyone, and confirms that the two match. Now, all Mojaloop messages are signed in this way, except for the original discovery request. And the reason the discovery request isn't signed is because at the time it's sent, the sending institution doesn't know what the recipient will be. The recipient is added by the switch. And therefore, you can't use JWS because it would appear that the message has been tampered with. What this means is that we have to have special mechanisms if the switch needs to make a change to something. That can be problematic, but it's a price we think worth paying to get this level of confidence that the original person really did send the message and that it hasn't been modified in transit. Final level of security is a two-phase commit. And this works in the following way. It uses the Interledger Protocol, ILP, which again is a publicly available definition. You can look it up. The way it works is as follows. The payee DFSP signs the agreed terms of the transfer, and it uses its private key to do that. It gets the signature, which is called a fulfillment, and it puts it through a public one-way hash. And the hashed result, which we call a condition, is what's returned to the payer DFSP. Now, a one-way hash, as I'm sure the technical among you will be aware, is an algorithm such that if you know the input, you can always generate the output, the correct output. But if you know the output, it's impossible to tell what the input is. So we'll see how this works. The payer DFSP and the switch retain the condition as they reserve the funds in the transfer process. And when the payee accepts the transfer, it returns the fulfillment to the switch and the payer DFSP. And don't forget, it returns that with a non-repudiation encryption attached. So everybody who gets that message can be sure that it was the payee DFSP who sent it. They can then pass the fulfillment through the same one-way hash, and the result should be the same as the condition which they got earlier. And if it is, they know that the payee said, I am happy with this transfer and I am going to clear it to my customer. So everybody can now be confident that the transfer has been completed successfully. So we now respond, the payee responds with a put, response to the quote, and the quote identification key, which is a UID, that the payer originally attached to the quote request. And it said, here is my response to your quote request. It's sent back to the payer DFSP, and that's the end of the agreement phase. Now, there's no obligation at this point on the payer to actually execute the transfer. It can decide whether to or not, and what it will normally do is it will send the information back to its customer saying, these are the terms on which the transfer will be completed. Are you happy? So the customer can reject the terms at that point, and the payer doesn't have to do anything else. It just doesn't send the eventual request for transfer. Similarly, the payee is not under any obligation at this point. If it sends back if the payer sends back a request to do the transfer and for some reason or another, the account is no longer in a state to accept that transfer, then the payee is perfectly within its rights to reject the request for transfer. Now, if a payee regularly rejects a request for transfer, then the scheme might investigate and say, why are you doing that? But in principle, nobody is yet committed to accepting or executing the transfer. That starts at this point. Pardon me. The payer DFSP reserves its funds, reserves the payer's funds in its account. And it sends something that just says, please send this amount as agreed. Now, the Mojaloop switch reserves those funds in its ledger. And as Miguel said, it checks to make sure that those funds are in fact covered by settlement funds deposited with the switch. It transfers transfers the request to the payee. And the payee, first of all, says, did I agree to this? Is the proposal the same as the one I agreed to with that condition? Is the content unchanged? Can I still make the transfer? Is it still possible to make that transfer to the customer's account? If it is, I retrieve the key and I send it back and say, well, I can do that transfer. I've accepted it and I've cleared the funds to my customer. Now, the switch checks to see that the key is correct. If it is, it confirms the funds transfer in the ledger. It then confirms to the payer DFSP and optionally to the payee DFSP that the transfer has been confirmed in the switch. Now, normally speaking, the payee should not need confirmation, but there may be circumstances where the transfer is of high value or involves cash that they want confirmation from the switch that the transfer has been registered as complete in the switch. And if they do, the payee can credit the funds to the payee. Now, the payer can check that the key is correct, debit the funds from the payer, and that's it. That's how it works. I'm just going to very briefly talk about how merchant request to pay works, and then I will hand you back to Miguel for the last session. So, what happens in a merchant request to pay? Customer winds up in a merchant who tells them the amount that there is to pay. The customer then says, please charge my phone, and gives the phone number or some other identifier. Now, the payee's DFSP says, who owns that identifier? We go through the same process as before, and the answer is it's owned by payer DFSP A. Yes, says the payer, I do own that. Customer. Now, the payee DFSP pardon me, can send a transaction request, which is a special type of API call that says, I would like you, pretty please, to ask your customer to pay me this amount. That goes to the payer's DFSP, which the payee already knows is the right DFSP because it issued a get parties beforehand. And now the payer DFSP responds to say, yes, I've got your request and I will action it. And next, it just goes through the process we've already been through. It just says, I will request a quote from the payee will respond, transfer request will go through in exactly the same way it went before. And that's how the detail of P2P transfers and merchant request to pay transfers work in Mojaloop. Thank you very much.